This is SpaceTime, Series 28, Episode 147, for broadcast on the 17th of December 2025. Coming up on SpaceTime, discovery of the longest gamma-ray burst ever detected, an elemental bounty discovered in a supernova remnant, and for the first time, the International Space Station is full up with no spare parking spaces available. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the longest gamma-ray burst ever detected, lasting over 7 hours, and in the process changing science's understanding about the death of the most massive stars. Astronomers have been trying to work out exactly what was responsible for this extraordinary cosmic explosion ever since it was first detected on July the 2nd. The initial observations have been reported in the monthly notices of the Royal Astronomical Society and in the Astrophysical Journal letters. Gamma-ray bursts are incredibly rare. Put simply, they're the most powerful explosions since the Big Bang of creation 13.8 billion years ago. And they come in two broad types. There are short-period gamma-ray bursts, which last just a few seconds and are thought to be caused by the merger of two neutron stars forming a black hole, or by the merger of a neutron star into a black hole. Then there are long-period gamma-ray bursts. They can last for more than 10 seconds and are thought to be caused by the explosive supernova deaths of the most massive stars, turning them into black holes. This specific gamma-ray burst, named GRB 250702b, continued not for hours but days and is now thought to have heralded a new kind of stellar explosion. Astronomers still think the best explanation for this outburst is a black hole consuming a star, but they disagree on exactly how this would have happened. Possibilities include a black hole weighing a few thousand times the mass of our Sun shredding a star that passed too close, or alternatively a much smaller black hole merging with and consuming its stellar companion. One of the study's authors, Eliza Knights from George Washington University and NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the initial wave of gamma rays lasted at least 7 hours, and that's nearly twice the duration of the longest gamma-ray burst previously seen. It was unlike anything observed in the last half-century, and it had some really unusual properties. On average, a gamma-ray burst is detected somewhere in the universe at least once a day. They can appear anywhere in the sky, without warning. Usually, they're very distant events, with even the closest known example erupting more than 100 million light-years away. But the record-setting duration of the July burst places it in a class by itself. Of the roughly 15,000 gamma-ray bursts observed since the phenomenon was first recognized back in 1973, none have been as long, and only around half a dozen have even come close. Because opportunities to study such events are so rare, and because many reveal new ways to create gamma-ray bursts, astronomers are especially excited about the July event. All gamma-ray bursts are thought to be generated by matter falling into a black hole. But not all the matter falling into a black hole is immediately consumed. Most of it first forms an accretion disk around the black hole. There it's crushed and torn apart at the subatomic level. Most will pass beyond the point of no return called the event horizon, after which it falls forever into the black hole singularity. But black holes are messy eaters, and some of the material is caught up in magnetic fields which channels the matter into tight jets of particles that stream out across the universe at almost the speed of light, in the process creating gamma rays as they go. The thing is, none of this is thought to be able to readily create jets able to keep firing for days on end, and that's why 250702b poses such a unique puzzle. The gamma-ray burst monitor on NASA's Fermi Gamma-ray Space Telescope discovered the burst and triggered multiple times over the course of 3 hours. It was also detected by the Burst Alert Telescope on NASA's Swift Space Telescope, the Russian Kronos instrument on NASA's WIND mission, the gamma-ray and neutron spectrometer on the Psyche spacecraft, that's the NASA mission currently on its way to the asteroid 16 Psyche, and by Japan's Monitor of All-Sky X-ray Image instrument aboard the International Space Station. The thing is, this burst went on for so long that no high-energy monitor in space was equipped to fully observe it. And so it took the combined power of instruments on multiple spacecraft to better understand the event. The Wide-Field X-ray telescope on China's Einstein probe also detected the burst in X-rays and showed that a signal was already present the previous day. The first precise location came early July 3rd when Swift's X-ray telescope imaged the burst in the constellation Scutum. That's near the crowded, dusty plain of our Milky Way galaxy. Now, given this location and the day earlier X-ray detection, astronomers initially wondered whether this might be a different type of outburst from somewhere within our own Milky Way galaxy. But images from some of the largest telescopes on Earth, including those at the Keck and Gemini observatories in Hawaii and the European Southern Observatory's VLT or Very Large Telescope in Chile, indicated that there was a galaxy at those coordinates. And so astronomers turned to NASA's Hubble Space Telescope for a clearer view. Andrew Levin from Radboud University in the Netherlands says it definitely is another galaxy, proving that it was a distant and powerful explosion, but he admits it was a very strange-looking one. He says the Hubble data is a bit ambiguous. It shows either two galaxies merging or one galaxy with a dark band of dust splitting the core into two pieces. And more recent images captured by NASA's Webb Space Telescope strongly support Levin's interpretation. The Webb observations clearly show the gamma-ray burst shining through this dust layer and spilling across the galaxy. In late August, astronomers using Webb and the Very Large Telescope to determine the galaxy's distance and other properties concluded that the burst was remarkably powerful, erupting with the equivalent energy emitted by 1,000 suns shining for 10 billion years. Amazingly, this galaxy is so far away that light from this explosion began racing outward some 8 billion years ago, long before our Sun and Solar System had even begun to form. A comprehensive study of the X-ray light following the main burst used observations from SWIFT, NASA's Chandra X-ray Observatory, and the agency's NuSTAR Nucleospectroscopic Telescope Array mission. The SWIFT and NuSTAR data revealed rapid flares occurring up to 2 days after the burst discovery. The continued accretion of matter by the black hole powered an outflow that produced these flares. But the process continued for far longer than possible in standard gamma-ray burst models. The late X-ray flares showed that the blast's power source simply refused to shut off, which means the black hole kept feeding for at least a few days after the initial eruption. The Fermi and Swift data indicate a typical, if unusually long, gamma-ray burst. But spectroscopic Webb observations didn't find a supernova explosion, which typically follows a stellar collapse gamma-ray burst, although it may have been obscured by its dust and distance. The Einstein probe saw X-rays a day before the burst, while NuSTAR tracked the X-ray flares up to 2 days after it, but neither was typical for gamma-ray bursts. In addition, a detailed study shows that the host galaxy appears to be very different from the typically small galaxies that host most stellar collapse gamma-ray bursts. It turns out this galaxy is surprisingly large, with more than twice the mass of our own Milky Way. Now, in both the two scenarios we've discussed here, the black hole should have consumed the star in about a day. The first involves an intermediate mass black hole, one with a few thousand solar masses and an event horizon a few times larger than the Earth. As a star wanders too close, it becomes stretched, spaghettified if you will, along its orbit by gravitational forces from the black hole, and is then rapidly consumed. This describes what astronomers call a tidal disruption event, but one caused by a rarely observed middleweight black hole with a mass much greater than those born in stellar collapses, and much smaller than the behemoth supermassive black holes found at the centers of galaxies. Right now, the gamma-ray team are favouring a different scenario because if this burst is like the others, the black hole's mass must be more similar to that of our Sun. Their model envisions a black hole with about 3 solar masses, with an event horizon just 18 kilometres across, orbiting and then merging with a companion star. The star would be of similar mass to the black hole, but much smaller than the Sun. That's because its hydrogen atmosphere has already been mostly stripped away, leaving just a dense helium core, forming an object which astronomers call a helium star. Now, in both cases, matter from the star first flows towards the black hole, then collects into a vast accretion disk from which material makes its final plunge into the black hole. At some point in this process, the system begins to shine bright in X-rays. Then, as the black hole rapidly consumes the star's matter, gamma-ray jets are blasted outwards. But notably, the helium star merger model makes a unique prediction. Once the black hole is totally immersed within the main body of the star, feasting on it from the inside, if you will, the energy it releases explodes the star and powers a supernova. Unfortunately, this explosion occurs behind enormous clouds of dust and gas, meaning even the power of the Webb Space Telescope wouldn't be enough to see the expected supernova. While the smoking gun evidence to explain exactly what happened on July the 2nd will have to wait for future events, GRB 250702b has already provided new insights into what is now the longest gamma-ray burst ever seen. This is SpaceTime. Still to come, astronomers have for the first time detected the elements chlorine and potassium in a supernova remnant, and the International Space Station has been forced to put out the fully occupied sign for the first time, with all 8 of its docking ports now in use. All that and more still to come on SpaceTime. Astronomers have for the first time ever detected the elements chlorine and potassium in a supernova remnant. The discovery, reported in the journal Nature Astronomy, was made using Crism, the X-ray imaging and spectroscopic mission spacecraft. Crism observed the elements in the supernova remnant Cassiopeia A, which are the remains of a star that exploded some 340 years ago. This expanding cloud of debris is located some 11,000 light-years away in the northern constellation Cassiopeia and is now some 10 light-years across. Other than hydrogen and helium, which were produced in the Big Bang 13.8 billion years ago, all the elements in our universe are manufactured in stars, either during their lives or when they die. This includes the iron in your blood and the calcium in your bones. Heat and pressure fuse lighter elements like carbon and oxygen into progressively heavier ones like neon and iron, creating onion-like layers of materials inside stars. But nuclear reactions also take place during explosive events like supernovae, which occur when a star runs out of fuel and collapses and explodes. Elemental abundances in different locations in a stellar wreckage can tell astronomers a lot about the progenitor star and its explosion, even after hundreds or thousands of years. Some elements, like oxygen, carbon and neon, are more common than others, and are therefore easier to detect and trace back to a particular part of a star's life. But other elements, like chlorine and potassium, are far more elusive. Since scientists have less data about them, it's more difficult to model where in a star they formed. But these rarer elements still play important roles in life on Earth. Potassium, for example, helps cells and muscles function, and so astronomers are interested in tracing its cosmic origins. This study's lead author, Toshiki Sato from Menjai University in Tokyo, says the discovery helps illustrate how the deaths of stars and life on Earth are fundamentally intertwined. As Carl Sagan once said, "We are all stardust." Now, thanks to Crism, astronomers have a better idea of when and how stars might make crucial yet harder to find elements. The roughly circular Cassiopeia A supernova remnant has a super-dense neutron star at its centre, the remains of the progenitor star's original core. Astronomers using NASA's Chandra X-ray Observatory had previously identified signatures for iron, silicon, sulfur and other elements within Cassiopeia A. In the hunt for other elements, the authors used Crism to look at the remnant in December of 2023, and they were able to pick out the signatures for chlorine and potassium, determining that the remnant contains much higher ratios than expected. They also detected a possible indication of phosphorus, which had previously already been discovered in Cassiopeia A through infrared observations. The study's authors think stellar activity could have disrupted the layers of nuclear fusion inside the star before it exploded. That kind of upheaval may have led to persistent large-scale churning of material inside the star that created the sorts of conditions where chlorine and potassium formed in abundance. The authors also combined their Crism observations with those from the Chandra Earth-orbiting X-ray telescope, showing that the elements were concentrated in the southeastern and northern parts of the remnant. This lopsided distribution may mean the star itself had undergone asymmetries before it exploded, something that the Chandra data had previously suggested. The authors had always suspected that a key part might be asymmetry, and now they have more evidence to support that hypothesis. But there's still a lot they don't understand about how stars explode and how they distribute all their elements across the cosmos. Being able to make measurements with good statistical precision of these rarer elements allows astronomers to develop a better understanding of the nuclear fusion process going on inside stars before and during their supernova explosions. And spacecraft like Crism helps to accelerate that understanding. This report from NASA TV.
Crism is our newest X-ray telescope in space. It's a JAXA-NASA collaborative mission with ESA participation and will revolutionize X-ray observations of the universe. It does this with a one-of-a-kind sensor that captures data with 36 super-cooled pixels. Yes, you heard that right. This groundbreaking detector isn't measured in megapixels, it's a 6x6 grid of 36 pixels. But they're unlike any others. Although this detector, called Resolve, can create low-resolution X-ray images, that is not what makes it unique. Each pixel in Resolve is a microcalorimeter, so it can measure tiny amounts of heat. A 6-stage system cools it to 50 millikelvins, or a fraction of a degree above absolute zero. This extreme low temperature allows Resolve to measure how much a pixel warms when it absorbs a single X-ray, and therefore measure the energy of that one particle of light. It's basically a precise way of measuring the X-ray's color. As a result, Crism can create the most detailed X-ray spectrum ever for distant objects. This spectrum can give a great deal of useful information, like temperature, what elements are present and in what quantities, and how fast an object is moving toward or away from us, even if we can only see it as a dot in the sky too distant to resolve details. This would be a revolutionary achievement for a detector with a single pixel, but Resolve has 36. This allows Crism to observe extended objects that aren't point source dots and create spectrum maps of their different regions. That can reveal speed and temperature differences in extremely hot gases. Using that information, scientists can determine how nebulae and galaxy clusters have evolved and interacted over time. The Resolve detector was invented and built at NASA's Goddard Space Flight Center. The detector's success in Crism will enable Goddard to further the design and follow up with X-ray microcalorimeters with hundreds or even thousands of pixels. So, while it may not sound as impressive as 4K or 50 megapixels, the Resolve detector on Crism will be revolutionizing our understanding of the large-scale, high-energy universe. And that's pretty amazing for a mere 36 pixels.
This is SpaceTime. Still to come, the International Space Station puts out the full up sign with no spare parking spaces available. And later in the science report, a new study claims flavonoids may help improve insulin resistance. All that and more still to come on SpaceTime. For the first time in its history, the International Space Station is fully occupied, with all 8 of its docking ports now in use. The houseful sign went up following the redocking of the Northrop Grumman Cygnus cargo ship under the Earth-facing port of the Unity module. The orbiting outpost is currently playing host to a pair of SpaceX Dragon spacecraft, the Cygnus cargo ship we just mentioned, JAXA's HTV-X1 cargo ship, 2 Roscosmos Soyuz capsules, and 2 Roscosmos Progress cargo ships. The Cygnus is flying Northrop Grumman's 23rd commercial resupply mission for NASA and was repositioned using the station's Canadarm2 robotic arm. NASA, Northrop Grumman and Roscosmos jointly planned the move to clear the way for the arrival of the Soyuz MS-28 spacecraft late last month and its new 3-person crew. The Cygnus is expected to remain docked until March, when it will depart loaded with up to 11,000 pounds of trash and excess gear and then re-enter Earth's atmosphere where it will burn up. Meanwhile, the 10-member Expedition 7374 crew are about to drop down to 7, with the scheduled departure of the Soyuz MS-27 spacecraft and its 3-person crew slated to undock from the Prakal module and return to Earth, landing in Kazakhstan. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims flavonoids, chemicals found in dark-coloured fruits, orange, citrus, tea, white wine and dark chocolate, may help improve insulin resistance. Previous research has linked flavonoid intake with benefits for cancer and blood pressure. Now, a report in the journal PLOS ONE examined data from Australian health and nutrition surveys showing a link between the intake of these foods and lower insulin resistance, a condition that can lead to type 2 diabetes and other metabolic events. Now, this type of study can't prove flavonoids are the reason for the link, but the authors say their lab tests were able to show evidence of flavonoids affecting insulin resistance in cells. The Israeli Defense Forces banned Chinese vehicles from their bases and production facilities, issuing blanket orders that any military personnel or civilian employees who own Chinese-made cars must park them well away from bases. The new IDF regulations are based on security concerns about data leaks from built-in cameras, GPS technology and other sensors which are fitted to these vehicles and which can be remotely controlled and monitored from China. The fear is images, audio or other data collected by these devices is being sent back to China and then handed over to Chinese intelligence agencies. Earlier this year, the United Kingdom imposed a similar ban on parking electric vehicles built with Chinese-manufactured parts near British military bases because of their own espionage fears. Concerns were also recently raised in Australia about Chinese-manufactured solar panels, batteries and inverters, which are equipped with unexplained additional communications technology, allowing Beijing to remotely control them and change their settings or turn them off without any local approval. And concerns about Chinese spying don't end there. In 2023, the Australian government began removing cameras made by Chinese companies from government facilities, also on the grounds of security. A new study suggests that over the past 50 years, top hit songs have grown to become simpler, more negative, and to contain more stress-related words. The finding, published in the journal Scientific Reports, analysed song lyrics from the Billboard Hot 100 charts between 1973 and 2023. Now that's some 2,186 songs, and have found that these changes in the lyrics coincided with increasing rates of depression and anxiety, and also with increased levels of negativity in the news media and literature. The authors also looked at major events, and they found that the Islamic terrorist attacks of September 11, 2001 and the beginning of the COVID-19 pandemic in 2019 were associated with lyrics becoming more complex and positive and containing fewer stress words, which the authors say might signify some form of escapism during stressful periods. After just a week, it's already clear that kids across Australia are easily getting around the federal government's social media ban for under 16s. The ban, which affects some 2 million children, was designed to protect them from cyberbullying and inappropriate material online. But it was highly selective in nature, not including gaming chat rooms or left-wing social media platforms like Blue Sky. But as forecast, kids are fighting back. Kids are easily getting around the restrictions by simply switching to a range of other platforms like Lemonade, Yope, WhatsApp and Coverstar, or by simply scanning an older friend's face, by using VPNs, or by using their parents' social media accounts. And the age verification technology itself has also turned out to be fairly poor, with many under 16-year-olds being judged as over 16 by the software. Technology editor Alex Zaharov-Reut from TechAdvice.life says all of these workarounds were always going to happen.
Well, I mean, that was already known before the ban came into place. There were stories of teenagers finding out how. But as Topher Field on X, who's a commentator, and was showing lots of information about voting and how to vote your preferences in the last federal election in Australia. He said, look, parents have an obligation to show and teach their children, because if they get around the social media ban and they can't talk to their parents because somebody has subjected them to online harm, which honestly we should teach the children how to deal with. If they've been subjected to something and, well, they can't talk to the teachers or the government about it because it's against the law, the only people they have left they can trust are their parents. If the children know how to get online safely and they can talk to their parents about it, we have some trust there, then not worried that your kids are going to be doing this thing behind your back, which is what the government rules have created, this reality. So, week one, it's chaos already. And of course, Albo, our Prime Minister, has said it's the finest thing he's done. All throughout history, I've seen this on X under Elon Musk and other people posting the same thing, but the people trying to censor speech are never the good guys. And that's really what it comes down to.
Now, you're a multiple award winner. You've won in creative writing, and this time you've won for controversy.
Yes. Well, there's the Consensus Group Awards. They've been giving awards for over 20 years, mainly to companies for their innovations in software, agricultural technology, medical technology, hardware. It's a business awards, but they also have an IT Writers Award, which has been going for just about as long. Well, it's the most controversial writer award, and it's an article I wrote about Telstra and their $10 a month discount, which removed a Wi-Fi 7 router that cost several $100s to buy if you bought it separately. It removes the 4G, 5G SIM card backup in case your wired connection goes down. If you were to have one of those from Telstra, it would cost you a lot more than $10 a month. You also miss out on the AI fix for any Wi-Fi problems that you have. And really, this discount makes it easy for Telstra not to serve you as a customer properly, and all for you to save a whopping 32.9 cents a day. So I just said this was a terrible discount, and Telstra was playing a joke on all of us to offer this. And their PR people said, it's competitive with the market. I said, well, it's still bad. And here I am a few months later winning an award for pointing that out. And I did tell Telstra about it, but I heard nothing back.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bitesz.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bitesz.com.